Okay, let's now to dig a bit deeper here and see what we get out of it. So our traditional data set, it has D features and it has M samples. Okay, now the yi here are Bernoulli distributed. So you have basically y is 1 or y is 0. Okay, so let's take a look at the maximum likelihood estimation. We know the formula. We need to find w's in such a way that the probability of seeing the data set D is the highest. This is what we try to do in maximum likelihood. We know that the yi's are Bernoulli distributed, so the probability of seeing the data given W is the product of the probabilities of these guys and these guys. But here your option is success or failure. So remember the PMF, or the probability distribution of Bernoulli, equals P for success, or 1 minus P for failure. If you wanna understand this a little bit better, go to my statistics refresher and you will see it. So we have the probability of the label given the features and the parameters, and we know that y predict is the sigmoid function of W transpose X, and this we will call alpha I. Okay, so if we calculate, if we use the PMF there, then we have again the product from I is 1 to M of alpha I, which is basically our rate of success, alpha I to the power of yi, times 1 minus alpha I to the power of 1 minus yi. This is the probability mass function of Bernoulli. Okay. So basically we could go on with this function and try to get somewhere, but I can save you a lot of time. This will not get you anywhere. If you try the other option, the MAP or the map A posterior, you will also not get anywhere. And the reason is because there is this nonlinearity. There is this nonlinearity hidden in these alphas here.